Every year, commercial planes are struck by lightning tens of thousands of times, and yet, if you're sitting in the cabin, you'd barely notice. No explosion, no fireball, no sudden emergency dive. At most, you might glimpse a flash or hear a distant bang, and then nothing. The flight continues smooth as ever, but behind that calm exterior, an incredible dance of physics and engineering unfolds in milliseconds. So what really happens when a bolt of lightning hits a modern aircraft? Let's break it down. First things first, lightning will hit airplanes. It's one of those unavoidable facts of flying. And funnily enough, airliners often trigger the strike themselves. As a plane flies through clouds, it gathers static charge. Fast-moving air rubs along the metal, separating positive and negative particles. Get enough imbalance and zap! The aircraft becomes the easiest path for lightning to follow. The strike typically hits the nose, runs along the fuselage, and escapes out a wingtip or the tail. So rather than being a helpless victim, the aircraft becomes a conductor, slicing right through the storm. But why don't you feel anything? It comes down to the Faraday cage effect. The metal skin of the plane forms a protective shell, channeling the electricity harmlessly around the outside and away from everyone inside. Aluminium does this beautifully, but newer planes, like the Boeing 787 or Airbus A350, are made with carbon fiber, which isn't as conductive. Engineers solve this by embedding metal mesh and copper strips under the paint, creating a planned path for lightning to follow. Let's walk through the bolt's journey. It hits the radome, the nose cone, coated in conductive material. The current, which can be upwards of 200,000 amps, travels over the plane's surface, guided by special bonding straps linking every panel and flap. The electricity looks for an exit, usually a wingtip, tail cone, or even an engine nacelle, where diverter strips help it jump safely back into the sky. All this happens in less than a millisecond. Inside the cabin, not even a flicker. Composite-aircraft add extra layers of copper mesh and shielding, especially around fuel tanks, to keep sparks and currents out of places they shouldn't be. And after every strike, engineers inspect the entry and exit points for tiny burn marks, test for hidden damage, and more often than not, send the plane back into the sky within hours. So, next time you see a flash outside your window during a storm, relax. The electricity is exactly where it belongs, outside, flowing harmlessly around you, as the aircraft shrugs off the sky's most spectacular light show.